Lagay ko lang yung ating view. So, yung view ay ayan. Okay. So, na-discover ko na para meron tayong representation ng lahat ng klase. Na-discover ko na pwede pala yun sa sa Google. Naka-tile. Ayan. So, naka-tile na yung ating setting. Pwede bang ayan, magsisimula na tayo. Welcome po. Bukas lang ng konti natin yung ating camera para lang mag-hello tayo. We're already nag-ano na ako ng video. Okay. Hello class. This is our second session, no? For computer architecture and assembly language, no? Tulad ng sinabi ko dun sa discussion natin kanina, no? Yung ating schedule is Tuesday, Friday. So, pagka Tuesday, yun yung discussion natin dun sa computer architecture with Stalling, yung ating pinaka-reference. Now, for Friday, okay, yung ating discussion, meron pa rin kay Stalling, and the other half would be assembly language, no? Binote out ko nga sa inyo yun beforehand. Sabi ko, gagamit tayo ng JVM for assembly language. Kaso yung ating PDF, yung na-download ko na PDF na para sa assembly language using JVM, hindi kumpleto yung instruction niya. Tsaka medyo mahihirapan tayo pagdating sa pag nag-apply na tayo yung sa projects, no? Walang masyadong pwede tayong mapaggamitan, no? So, instead na yun ang gagamitin natin, so magnanasam tayo. Nasam. Yun yung pinapakita ko sa inyo kanina, no? Kasi sinasam, at least kompleto. Meron siyang tutorial na pwede nating sundan, no? Pwede tayong mag-code, no? Ayan. Tapos, pwede rin tayong maghanap ng source code ng NASAM doon sa application ng ating project. To. Kung ano man yung maiisip ninyo. Ayan. Okay. So, doon mas maganda yung ganun kaysa yung sumubok tayo ng JVM. As in, pare-pareho tayong blind, no? Wala kayong mapapagamitan na application ng nung assembly language. So, at least sa NASA, maraming references na pwede tayong magamit. Lalo na dun sa tutorial. Hindi tayo mahihirapan. Okay? So, yun yung approach natin, no? Ino-open ko lang sa inyo para aware kayo, no? Ayoko namang ma-shortchange kayo. Matapos tong wala tayong nagawa. Ayan. Okay. So, dun tayo sa discussion natin ng yung kay Stalling, no? Okay. So, dito, yung ating i-discuss ngayon is about IOs. Okay. Yan. So, mga computer components, ano yung function nila? Mga IO function, bus interconnection, no? Yung point-to-point, no? Mga layering sa network, link, routing, tsaka protocol, tsaka yung ating PCI. So, yan yung ating i-discuss ngayon. So, sandali lang yan kasi papahapyawan lang natin, no? Okay. Okay. Nakikita nyo ba yung screen?
Hindi po.
Okay.
Hindi po.
Sorry naman. Ayan. Sige, entire screen na lang para pwede akong maglipat kahit saan. Okay. So, ayan. Nakikita nyo na? Nakikita nyo na po?
Yes.
Yes po.
Okay. So, ganito lang, no? Hindi ko mai-full screen kasi mamaya maputol na naman yung ating, yung ating recording, no? Okay. So, again, I/O yung pag-uusapan natin, tsaka PCI na computer component, no? So, anong meron dyan? Again, historical background, no? Yung design ni John von Neumann ng I/O. Okay. Yung Neumann architecture, yan. Okay. So, yan yung pag-uusapan natin. Tsaka yung PCI. May idea ba kayo kung ano ibig sabihin ng PCI? Anong idea niya ng PCI?
Peripheral interface, peripheral component interconnect.
Peripheral I/O. Sige, papakita ko na. Hintayin lang natin. So, mga bus sa network. Ayan. So, yung PCI, teka lang, sandali, malapit na. Ayan. Peripheral Component Interconnect. Ayan. Yung PCI. Yung connection, no? Ayan. So, ayan yung typical na configuration ng ng PCI, no? So, meron kang core, chipset. Ayan. Okay. So, simulan na natin. Okay, so component pa rin ang pinag-uusapan natin kasi we're talking naman about architecture, no? Okay, so computer components, contemporary computer designs are based on concept, no? So this was developed by John von Neumann from the from IAS, no? Institute of Advanced Studies sa Princeton, no? Sa IAS. Okay, siguro naririnig niyo yung IAS. Ano kaya yung IAS na yan? So, eskwelahan yan, no? Dun sa mga computer components na dinesign ni John von Neumann, no? Si John von Neumann, ang ginawa niyang architecture, merong tatlong concept dun sa computer components. Okay, first, you have the data and instruction. Okay, they are stored in a single read-write memory. Tapos, contents and its this memory are addressable by location. Okay, wala siyang regard doon sa data na laman niya or type ng data contained, no? So next is the execution, no? So yun yung three concept, no? Data and instruction, contents in the memory, and execution, no? Execution, paano, no? It's either sequential or instruction based. Ayan. Okay. So yung computer components, that is hardware program, that's the result of the process of connecting various components. So ano ba yung mga components na yan? Okay, so here, ito yung ating hardware software approach. Okay, so from data and then sequence, you have here the logic and then the result. Yan yung pagpo-program ng hardware. Or via instruction, you have an interpreter. Okay, dadaan sa control signal, papasok sa data, i-interpret, no? And then you have the result. Programming by software, no? Ayan. Yan yung mga approach. Now, balik tayo dun sa components. Okay? Ito yung component niya, no? So, you have software. Okay? And then you have hardware components. So, software, you have a sequence of codes or instruction. Okay. Part of the hardware interprets each instruction that generates control signals. Siyempre, batingting ng batingting yung cellphone, no? Ang ingay. Okay. It provides a sequence of code, no? For each program. So, kung pagdating sa software, speaking of hardware, sino nagpapatakbo sa hardware? So we have OS, no, yung mga OS. Yan lang naman ang kadikit ni ano eh, ni components, no? Tapos you have your major components na hardware. You have your CPU, siya yung nagre-receive ng instruction, and then you have your I/O. Okay, so dun sa I/O, syempre yan yung input-output module. Okay, siya yung nagre-receive ng signals para i-report yung result, no? Ayan. So, dun sa components, okay, yung main component dito is yung memory at saka yung I/O, no? So, si I/O, nagre-receive siya ng signal, tapos ini-interpret ni memory. Okay, lalabas siya, no? Okay. So, ito yung computer components. So, ito yung CPU. You have here the memory. And then, from here, lumalabas siya as instruction, either by software or by hardware. So, sinabi dito, yung instruction ng code, pwedeng lumabas as a software, at meron ding instruction na galing sa CPU, no? Ayan. Ayan. No? Okay. So, computer components. Ito yung basic instruction na cycle. You start, and then you fetch, and then you execute, tapos halt. Ganun lang kasimple. Pagdating kasi sa hardware, ganun lang naman kasimple. Ipapasok lang yung instruction ng software. Katulad ng pagka nagbo-boot ka, 'di ba? Pag nagbo-boot ka ng OS, dire-diretso lang yung ano niya. Hindi katulad ng mga application software, no? Madami kang pwedeng gawin, no? Pero sa OS, straightforward lang pagbukas, no? Yun na yun, no? Ayan. Now, yung fetch cycle na dire-diretso, there is a beginning, no? The instruction cycle, no? And then, papasok siya sa program counter, which holds the address. Pag tinawag yung address, papasok siya sa processor, magkakaroon ng increment, ipe-fetch yung instruction, ilo-load sa register, and then, i-interpret siya ng processor, and then, ipe-perform siya. So, ayan. Dire-diretso lang siya, no? From start, to fetch, to execute, to halt. Yan. Yan yung fetch cycle. Okay. Ito yung mga pagpaprocess using the memory. No? Ayan. So, yung I/O umiikot, no? Yan yung action category niya. Okay? Dun sa processing ng memory, syempre, sinong ina-access niya? Data. No? Dun sa pagpaprocess ng input-output, sinong ina-access? Si processor, no? Okay, sa data pa rin. Now, pagdating dun sa control, you have there an instruction that is specify kung ano yung i-execute, no? Kaya control. And then, data processing, umiikot yan, no? Ganyan yung pagpaprocess ng action category, no? Okay. The processor may perform some arithmetic or logic operation on the data. So, depende kung paano ano yung pinaprocess na data sa background, no? Yan. Okay. Now we have characteristic of a hypothetical machine. Yung machine na inire-represent dito, hindi niya sinabi, hypothetical nga, no? Okay, so you have here a program counter, the address of the instruction, and then the instruction being executed, the accumulator, temporary storage, Okay. And then, yung load niya, no? So, from 0 to 1, load niya AC from memory. Okay. 0 to 1. Okay. From here, 0 to 1, yan yung loading ng memory. Okay. So, nire-represent siya ng opcode, no? So, yung sa addressing. Pag nagsimula na tayo ng NASAM, makikita nyo doon yung addressing. Meron tayong computation na gagawin pagdating sa addressing, no? Okay. So, may instruction format para ma-address yung counter, kung ano man yung ibinibigay na address para i-process ng ating machine, no? Okay. Yan. So, pag-aaralan natin yung addressing na yan once we do assembly language programming. Okay. Yan, no? So, ito yung mga register. Yan yung gagawin natin. Magko-compute tayo. Memory computation. CPU register computation. Ayan. So, bakit natin gagawin yan? Pag nagsimula na tayo ng NASAM. Kasi kasama yan dun sa code na ipoprogram natin dun sa assembly language. So, mas maintindihan nyo yan pagka nag-code na tayo ng assembly language, no? So, okay. Yung entry ng memory para ano yung i-assign mo para sa gusto mong ilabas na output dun sa assembly language. Yan. Next. Okay. So, this is an instruction cycle state diagram. Again, ayan, dun sa component, andyan yung fetch. So, once na nag-start yung ang process, no, nag-set ng instruction sa fetch, dinala sa address, ayan, sinend sa instruction operation, dinicode. Okay. Ayan, so, naging operand siya, and then, naging data operation. Ayan. So, nagre-return. Ayan, ang vector. Okay. Ayan yung execution. Okay, so, ito naman yung classes ng interrupts. Yung interrupt, nangyayari yan pagdating dun sa input-output, no? Yung interrupt, it's a normal processing ng processor, no? Normal yan. Now, yung may value yung dapat na interrupts, no? Okay. So, you have here, these are the classes. You have here a program, a timer, an input-output, and then you have a hardware failure, no? So, pag nag-hardware failure, magja-generate siya ng memory parity error. Okay. So, tingnan natin yung program. Siguro pwede na akong tumawag at ako na lang yung nagsasalita. Ginawa ko lang yan para mabilis yung discussion natin. Binibilisan ko na kasi may kalahati tayo ng assembly language, no? Okay. So, dahil masakit na yung lalamunan ko, pwede na akong tumawag. Nakikita nyo ba yung screen? Hindi. Sige, ililipat ko. Ayan. Ilipat ko lang. Ayan. Para hindi nyo ako tulugan, alam kong may nakikinig sa akin. Ganito sa assembly, medyo nakakaburyong, no? Pero pagdating ng nag-program na tayo, mas exciting na yan. Okay. Mas exciting kasi mas makukulta yung utak natin. Ayan. Okay, so ano yung mga classes of interrupts? Okay. Tawagin nga natin. So, simulan na natin kay Aaron. Aaron, yung program, ano raw yun? Yung class na program.
Program generated by some condition that occurs as a result of an instruction execution, such as arithmetic overflow, division by zero, attempt to execute an illegal machine instruction, or reference outside the user's allowed memory space.
Ayan. So, yan yung class ng interrupt na nagja-generate ng condition, no? So, nag-execute siya ng instruction, no? Yung mga program na nakikita nyo, yan, okay yan, no? Walang problema yan. So, yung mga interrupts kasi, merong interrupts na pag sumobra ka na doon sa allowable, anong mangyayari sa machine, no? Magkakaroon siya ng illegal execution, no? So, pero pagdating sa program, yan na yung naka-condition kasi yan eh. So, gene-generate na yung condition. Ayan. Meron siyang allowable na memory space. So, walang issue. Now, yun namang timer. Timer, cherry yan.
Timer. Generated by a timer within the processor. This allows the operating system to perform certain functions on a regular basis.
Okay. So, naranasan nyo na ba na yung machine ninyo dahil, hindi. Sino yung maingat tapos dahil matanda na yung machine, naririnig nyo na yung clicking. Yung hardware nyo nakakarinig na kayo ng clicking. Parang malapit na siyang, alam mo yun, na malapit na masira yung machine. Yung masyado ng maingay. Sino yung nakaranas na ng ganun? Sino yung nakaranas ng ganun? Yung kanilang machine, yung kanilang PC. Or sino sa inyo recently nagpalit lang ng PC? Or laptop? Yung pants lang po man, dati yung PC ko. Oh. Yung maingay na talaga, sino yung nakaranas? Yung kailangan mo ng tapatan ng ng electric fan kasi maingay na masyado. Kasi pagka maingay, ibig sabihin, yung clocking ng timer, malapit nang mag-fail. Yun yung kaya tinatanong ko sa inyo kung may nakaranas na sa inyo eh. Ayan. So, yung iba, anong ginawa mo, Juan Paulo? Nagpalit ka ba ng pan? Or yung pans mismo ang maingay?
Nagpalit po ng PC.
Nagpalit ng PC.
Opo, luma na po kasi talaga yun. Pati po yung mga specs, pababa.
Kasi ang sa akin, ang naranasan ko, yung lumang kasi yun yung lumang processor, yung sinasalpak mo, yung nasa ilalim ng processor ay pan na umiikot. Kaya maingay, no? Dahil umiinit na siya, so, ang unang maapektuhan yung nasa ibabaw, which is yung processor. So, yun, yung timer niya, hindi na hindi na yung standard na interrupts, no? Kasi meron tayong standard na interrupts yung sending ng signal dire-diretso lang ganun. Pero pagka kasi yung device mo malapit nang mag-fail, yung timer niya nagfe-fail din. Ayan. Yan. So para lang ma-picture niyo yung pinag-uusapan natin, no. Ayan. Okay. So next si si Francis, yung IO. Francis Pelias. Nakatulugan mo na ba ako? Sige. Wala kang audio, Francis. Ano nangyari?
Dinig na ako.
Ayan, dinig ka na. Finally. Sige.
IO. Generated by an IO controller to signal normal completion of an operation. Request service from the processor or to signal a variety of error conditions.
Ayan. Okay. So, yung IO natin, yung input-output natin, no, yung IO controller, siya yung nagsasend ng signal. Siya yung nagsasabi kung normal pa ba yung ano. Kung hindi na, no, magsisend din siya ng error condition, no? Ayan. Okay. So, yung last natin na interrupt, yung hardware failure, no? It is generated once there's a power failure, no? Yung memory parity, nagsisend siya ng error, no? Nangyayari yan pagka walang power. Ayan. Okay. Right. Lipat ko lang sandali. Lipat ko lang. Bilisan natin para makapagsimula tayo ng assembly language. So, ito ang program flow control with or without interrupts. Ayan. No? So, yan tumatakbo. Ngayon tumatakbo yung interrupts natin, whether merong interrupts or wala. No? Yung flow ng control. So, from user, i-write yung instruction, papasok sa program, i-execute yung program, mag-e-end. Ayan. Ayan. No interrupts, with interrupts, zero wait, short wait, long wait. Ayan. So, ganyan yung process niya. Okay. Pakita ko lang sa inyo. Ayan. And then, interrupt occurs. Ayan. So, transfer ng control via interrupts. Ayan. So, user program, interrupt by handler. Ayan. Fetch. Dire-diretso lang din yan. Okay. And din lang yung pinag-usapan natin kanina, no? Yan yung instruction cycle niya. You have your start, and then you fetch instruction, you execute instruction, and then you check. Pag na-check na, halt. Ayan. Okay. IO operation. Ayan. Okay. Program timing, no? Short IO wait. Ito, short lang siya, no? So, ipaprocess, mag-iintay. Ipaprocess, mag-iintay. Okay. Yan yung long. Ito yung cycle ng diagram with interrupts. Okay. Again, dire-diretso lang siya. Kasi hindi naman siya katulad ng application na maraming pwedeng gawin, no? Isang straightforward lang naman na instruction yan. Isisend yung instruction, gagawin yung instruction, and then magka-calculate, and then gagawin yung operation, and then babalik, no? Paikot. Kita nyo naman pagka sa system, diba? Pag nag-open tayo ng OS, dire-diretso lang yan, no? It goes in a sequence, no? Pati yung interrupt, ganun din. Ayan. That's a transfer of control and multiple interrupts. Okay. There you go. That's the time sequence. Time sequence. Okay. Okay. Now, let's look at the IO function, no? Okay. Lipat ko lang para kayo naman ang mag-talkies. Okay, so let's look at the function of I.O. Tingnan nga natin yung first function. Basa po, Miss Kabaod. G ba, Caro? G?
First bullet, I/O module can exchange data directly with the processor.
Okay. So, tuloy mo lang. Sige.
Second bullet, processor can read data from or write data to an I/O module. Sub-bullet, processor identifies a specific device that is controlled by a particular I/O module. Second sub-bullet, I/O instructions rather than memory referencing instructions.
Yan. So, yung I/O function natin, okay, like I said, it's a matter of signal, ano? So, ang pinaprocess niya, ine-exchange na lang yung sinesend na signal, no? Ine-exchange niya directly with the processor. The processor can read the data or write data in the I/O module, and then it identifies the device kung saan siya isinesend, no? Ng module. So, instruction from the I/O and then referencing it to the memory. Ayan. Okay. So, yung next na bullet, si John Nicole.
In some cases, it is desirable to allow I/O exchanges to occur directly with memory. The processor grants an I/O module the authority to read from or write to memory so that the I/O memory transfer can occur without tying up the processor. The I/O module issues read or write commands to memory, relieving the processor of responsibility for the exchange. This operation is known as direct memory access.
DMA. So, yung I/O, yung function niya, ito yung pinakamaganda dahil direct yung memory, no? Yung exchange. Yan yung pinaka-desirable, no? Kasi yung signaling mas maganda at yung command mas madaling mapaprocess, no? So, yan yung function ng I/O dyan, no? So, once na nag-send na ng instruction, no? Yung reading and writing command diretso sa memory, responsibility na yun ng processor, no? Which is sinisend ng signal natin, which is your I/O. Yan yung sa function niya. Ayan. Okay. Okay. Siyempre, lilipat ko ro yung sandali. Lipat ko lang. Ayan. Ayan. So, this is our computer modules. Yan. Okay, you send your read and write signal to the memory. It goes out as a data, no? You send read and write signal, you address sa I/O, and it sends as an internal data or external data. Okay, so meron siyang interrupt na signal. Instruction sent to the CPU data, no? And it goes out as an address, control signal, and a data, no? So, yan yung ating mga computer modules. Okay, so these are the interconnection structure that support the following types of transfer. So, you have memory to processor transfer, processor to memory, I/O to processor, processor to I/O, I/O to or from memory, no? Dun sa memory to processor, processor reads the instruction or a unit or data from memory, no? So, processor to memory, it writes the unit of data, no? From I/O to processor, processor reads the data from I/O to the device to the I/O module. Ayan. So, ganyan yung interconnection ng structure, no? Okay? And it support these types of transfer. Ayan. Okay. Nakikita nyo yung interaction ng ating computer components, no? Ayan. So, ito yung ating communication pathway, no? Right. Nakikita nyo, napansin nyo yung ating arrow, no? From here, yung ating devices, nagsisend ng signal, tinatransmit ng device. Okay, papasok siya sa aray nako. Okay, papasok siya as a multiple communication line. Okay, represented by a signal na zeros and 1. And then the computer system that contains this signal, nakabus yung niya, pathway, no? And then the computer system with sisirain mo yung gamit ko. Aray nako. Okay. Siya, yung ginamit dito na example, naka-bus, no? Familiar kayo dun sa networking natin na na yung bus, star, na hub, yung hub, no? Ayan. And then between components, the levels of computer system hierarchy, no? And then ayan, system bus, no? The bus that connects to the I/O and the memory, and then the most common computer interconnection structure, the system bus. Meron na kayong networking na, teka, third year na kayo, at least alam ko meron na kayong meron na kayong pati sa K-12 ata merong networking, or depende sa school. May school na programming yung concentration, may school na networking. So kung familiar kayo sa networking, meron tayong mga types ng network. Meron tayong bus, merong hub, may star, ayan. So dito sinample yung system bus, no? So bus, yung bus parang katulad ng fetch, dire-diretso lang siya, no? Okay, para siyang highway na dire-diretso lang. Hindi katulad nung isa, yung star, no, para siyang paikot, no? Okay. Yung dinadaanan ng network, no? Pag nag-set up ka ng network, ano ba siya? Diretso, no? PC to PC, ganun. Yun. Data bus. Ayan, data bus. Okay. So, yung data bus, teka, balik ko lang sa natin para kayo naman. Ayan. So, ano naman yung meron doon sa data bus? Okay. Si Ken Nokun.
Data lines that provide a path for moving data among system modules.
Okay. So, siya yung nagmo-move. Okay. Diretso. Sige.
May consist of 32, 64, 128 or more separate lines.
Okay. Sige, diretso.
The number of lines is referred to as the width of the data bus.
Okay. Sige.
The number of lines determines how many bits can be transferred at a time.
Ayan. Tapos,
the width of the bus is a key factor in determining overall system performance.
okay. So, yung bus, yan yung nag-deliver, no? Sa kanya tumatakbo yung data, no? Meron siyang naka-assign na bits per transfer. Okay. So, tingnan natin yung next screen para ma-picture nyo yung sinasabi niya. Sandali. Ilipat ko lang yung ating ayan. Ayan. So, yan yung ating address bus, no? So, bus used to designate the source or destination of the data. So, ito yung bus na data bus, no? Okay. sa iyong nagbibitbit ng data dun sa address sa IO ports, no? And then papasok dun sa control bus, dun sa access. Ito yan, no? Nasaan yung ating screen kanina? Okay. Yan. Ayan. Ayan, no? Yan yung pinapakita dun sa ating yung data operation, no? Yung dire-diretsong fetching ng bus, data bus, no? Pagpasok dun sa fetch. Yan. Tapos diretso ng address bus. Tapos pasok sa control bus, no? Ito yung ating yan. Yung pag-execute ng ating hindi na nata. Lumampas ako. Ito. Ayan. No? So, doon sa operation ng data, no? Okay. Ayan. Okay. So, ayan. Okay, and then ayan, no? So this is the bus interconnection scheme. So from your CPU to the memory to the IO, the control lines, and then the address line, the data lines, no? So ito yung ating bus, no? Pansin nyo, magkaka-connect sila, no? Balikan natin, no? So your data bus, ayan. Okay, ito. From your CPU to the memory to the IO, the signaling, no? And then the address, yung connection nila, and then the control, no? Control. So this is the interconnection scheme. Mas madali kasing ipakita na lang sa inyo eh. Mas madaling makita, no? So, point to point yung interconnection nila, no? So, there's a reason bakit meron tayong point to point interconnect, no? Dahil dun sa electrical, no? Alam nyo naman yung ating hardware, kaya yan tumatakbo dahil sa electrical signal na sinesend, no? So, kung wala tayong power, depende yan sa latency na gamit, no? So, yan yung connection, no? So, you have here the shared bus, the chip, okay? And then the latency, no? Data rate per scalability. Yan. Quick Path Interconnect, QPI. This was introduced 2008. This is a multiple direct connection. Yung pairing niya, pairwise connection, eliminates arbitrary shared transmission system. Naka-layer na yung protocol ng architecture. Nakapacket yung data transfer, no? Kung naaalala nyo yung networking, networking architecture, no? So, dito nagsimula yung layer, no? Nakapacket yung transfer ng data. Yan. Kanapin ko lang sandali yung network architecture para napipicture natin yung ating discussion. Google. Topology. Ayun, yung topology, naalala ko na. Yung bus, star, 2-tier, ayan, 3-tier, peer-to-peer. Ayan. Kanina ko pa iniisip eh. Peer-to-peer, star, hub, bus. Ayan. Di kasi ako ng network. Transfer. Teka. Ito, mas maganda to para mas ma-appreciate nyo yung discussion natin. Nabobor yung iba dyan. Tutulugan nyo na ako eh. Okay. Kunin ko lang tong image na to para mas ma-appreciate natin yung discussion natin. Teka lang. Okay. Saan ka? Bakit sa Pinterest ka nagpunta? Okay. Ano ko to bubuksan? Dito ka sa site. Yun. Ayan. Okay. Share ko lang. Okay. Saan na? Ayan. Stop sharing. Okay. Window. Cancel. Dapat or enter screen. Ayan, share. So, eto na tayo. Ito yung ating pinag-uusapan, multi-core configuration, no? Quick path interconnect, no? So, yung QPI, inintroduce siya noong 2008, no? Naka-layer na yung ating protocol architecture, no? Nakapacket na yung data transfer. Yan, dyan nagsimula yan. Okay. So, ganito yung multi-core configuration ng QPI. No? So, andyan yung device mo, no? Okay. So, ito yung sinasabi ko, no? Yan. So, ito yung ating isang buong no, configuration ng isang system, no? So, yung takbo ng ating computer components, no? Yan. So, may sinasabi ako mula dun sa computer server, no? Yung ating pasok pagdating sa electrical, no? Okay. Ayan. Dito. Dun sa signaling, no? Dun sa interconnection natin, no? So, may epekto yan. Ayan. Yung discussion kanina, ibinalik ko lang. Okay. So, balik tayo dun sa ating QPI, no? So, again, yun nga yung ating protocol ng architecture. Nag-layered na siya noong 2008, to. Ayan. So, yun yung simula ng transfer, ng data transfer into yung from your halimbawa from email, tapos papasok siya dun sa ano nyo, tapos papasok sa network, tapos bubuuin siya, lalabas siya sa mga sa mga hindi ko maalala yung transfer na yun. Teka lang nga, sandali lang. Network teka, processing ng data transfer process in the network. Anong tawag doon? May process yun eh. My God, ang aking memory. Ayan, nakita ko rin. Sabi ko na eh, maalala ko rin yan eh. Ayan, this is what I mean. This is what I'm trying to explain sa network natin. Ayan, so from application layer to presentation layer, session layer, transfer layer, data link. Ayan. Yan yung sinasabi kong kanina ko pang iniintindi ko, inaalala ko, no? So, nagsisimula sa application layer, no? Tapos, hahati-hatiin siya ng presentation layer, ayan. And then, naging session layer siya, itatransfer siya, papasok siya sa network, dadaan sa addressing, i-ano siya, isi-send siya through a data link layer, and then physical layer, bubuin siya uli, no? Okay, ilalabas ng ating, ayan, signal, no? Finally, kanina ko pa ito inaalala, eh, no? So, yan yung layer na, para ma-appreciate niyo yung discussion natin ng ano ito, no. So dito yan nagsimula nung 2008, naka-layer na yung protocol ng architecture. Ayun. Ayan. So again, ayan, multi-core configuration using QPI. You have here an IO hub, and then core, and then core. So ang daming core dito, no. Ayan. So, yung transfer niya, okay, either moving here or moving there, depende kung saan ang takbo, no? So, you have your QPI, your quick path interconnect, ni-layer niya na, no? Ayan. So, yung dinadaanan niya, yung PCI, at saka yung memory bus. Ayan. Okay. Ayan. So, ito yung ano niya, no? So, meron siyang protocol dyan through packets, nira-route niya, and then you have your link, and then you have bits, no? So, physical, no? Yan yung QPI layer, no? So, nag-i-improve na, no? Tapos, aabot tayo dun sa latest, which is ito, yan. Ito yung pinaka-latest, no? Yung ating official na takbo ng ano ng data, no? From application to presentation to session, no? Nakikita nyo ba yung screen? Doon sa may background ng networking, siguro naman naintindihan nyo yung ine-explain ko, no? Kasi ang hirap ipaliwanag itong ano, kasi ito yung lumang version, no? So, itong QPI. Kasi nasa ano tayo, historical data eh. So, pa-improve ng pa-improve, no? So, ayan na, nag-QPI na tayo. In the end, yun yung layer, no? Ayan. Okay, so this is the yung screen ko ba ay ano, ay yung ating PowerPoint. Nakikita nyo ba yung PowerPoint? Ayan. Hindi. Ayan. Nakikita na yung PowerPoint natin?
Instant na po.
Okay. So, gusto ko kasing ma-appreciate nyo yung discussion natin. Kaso, we are going through historical ng ating computer architecture. So, ito, pa-improve tayo ng pa-improve, no? Itong QPI, Okay, sa history, ayan, 2008 yan. So, layered protocol architecture na introduced dyan. Noong 2008, no? So, kung ma-appreciate nyo yung ipinakita ko, dun sa mga familiar sa network, layer, eto, no? Eto na yung pinaka-latest, no? Yan na yung tumatakbo in present time, no? So, tingnan nyo, naka-layer na siya. Incorporated na yung layering. Yan. Dito sa discussion natin, luma pa, no? Ayan. Ang naka-layer lang yung protocol. Okay, yung interconnection. Okay. So, paano nyo makikita yan? Dito, no? Yung PCI, QPI, no? Dun sa multi-core configuration using QPI. Ayan. Okay. So, ito yung ating protocol routing, no? So, ano lang siya, back to back, no? Back to back yung picture niya, no? Ayan. So, ito yung physical interface, no? Dun sa Intel, ano ba to? Intel QPI Interconnect. No? Luma pa rin to, no? Ayan. Actually, wala nang ganyan ngayon. Siguro sa museum nyo na lang makikita yan. So, ito yung QPI multi-lane distribution, no? So, ang distribution niya, pag ganyan, bit stream, naka-split, no? Ayan. Again, ma-appreciate nyo yung ating latest na layer kasi pababa na siya, no? Pababa yung distribution, no? Malinaw. You have an application, you have a presentation, you have a session, you have a transport, you have a network, yan, data, physical layer. Yan. So, mas ma-appreciate nyo yan, no? Kaysa dito sa QPI. Yan. Okay. Okay, so you have here a QPI link layer. So, dalawang pinaperform niya. You have the flow control and the error control. No? Yan. Okay. Hindi ko na masyadong kasi we're just going through historical, no? Okay. So, pagdating naman sa, sa midterm natin, application tayo. So, so, ang akin lang ay binibigyan ko lang kayo ng historical background, no? So, yung sa ating mga exam, kung iisipin niyo yung ating midterm, doon kayo mag-concentrate pag nag-code na tayo ng assembly. Yun, mas importante sa akin yun. Doon ako, wag nakapag-code tayo, yun na yung, bali application yung aking exam, no? So, ito, pinapahapyawan ko lang kung ano yung historical natin na development ng mga components natin sa architecture, computer components. Okay, so QPI routing and protocol layer. So you have here a routing layer and then you have the protocol layer. So sa routing, ito yung nagde-determine ng course ng packets, no? Ayan. So naka-layer din siya, no? It is defined by the firmware. So, yung firmware mo, siya yung nagsaset ng packets, possible paths, no? And then, you have here a protocol layer. The packet is defined as a unit of transfer, no? So, one key function performed, yung cache coherence, no? So, dapat maayos, coherent yung natin. Yan. Okay. Okay. Ayan. So, ayan na yung PCI. Okay. Physical, Peripheral Component Interconnect, no? PCI. This is a popular high bandwidth processor independent bus. So, that can function as a mezzanine or a peripheral. No? Ayan. So, again, pa-improve tayo ng pa-improve. Nagkaroon na ng PCI. Ayan. Ito yung kanyang typical configuration, PCIe. Okay, you have there the chipset and then the switches. Okay. Legacy endpoints. Ayan yung PCI endpoints. Masakit. Nangangagat ka. Okay, so you have here the protocol layers. Ayan. Sa historical data, wala na yan eh, pero at least para alam lang natin, no? Ayan. And yan yung kanilang multi-lane distribution. Ayan. PCI multi-lane distribution. Naka-byte stream. Okay. And then you have here the transmission. Paano siya nagtatransmit at nagre-receive. Okay, you have here the scrambler and then mag-encode and then you have a parallel serial. Parallel to serial, ayan. Wala nang ganyan ngayon. Puro direct ano na tayo. Then you have the transmitter, differential driver. Ayan. That's the transmitter. Dito meron kang receiver from the differential receiver and then you have data recovery, serial parallel, decoding, the scrambler. Ayan. Ganyan dun sa PCI. Okay. So, nag-improve siya. Yung ano niya, yung pumasok na dyan yung transaction layer. Okay. Okay. So, nagre-receive na siya. At nagra-write ng request, read and write. Split yung transaction. Okay. And then, ang message ng write transaction, nagpo-post siya. Ayan. Nag-i-improve, no? Ito yung memory configuration niya. Okay, you have the memory space. There are certain ranges. The configuration of the address, the I/O legacy, and then the message space. Ayan. Okay. So, ito yung ating table ng PCIe TLP transaction types. So, yung sa memory, meron dyang memory read request and then memory read lock request. Ang purpose niya to transfer data. Yung I/O, okay, transfer data from location to system memory. Yung configuration para lang sa read and request transfer. And then meron kang message dyan, message request with data. Okay. Yan. Yan po yung ating transaction type. Ito yung PCIe protocol data unit format. Ayan. O, diba? Natapos na natin. Okay. So, yun yung computer components. Ayan. Interconnection. Okay. Pinahapyawan ko lang, no? Para makapagsimula na tayo ng assembly language. Okay. Ayan. So, pwede na tayong mag-assembly language. Yes. Ayan, meron pa tayong 30 minutes. Salamat naman. Ayan. Okay. Okay, so ganito yung gagamitin natin. Para ma-applyan na natin, makita natin yung pinagdi-discuss natin ng mga lumang system. No? Ayan. So, sinasam po ang ating gagamitin, no? Nasam. Nasaan sinasam? Okay. Okay. Check muna natin. Check muna natin kung gising pa kayo. Natapos na natin yung ating gising pa ba? Gising pa? Hindi nyo ba ako tinulugan? Diretso ko na para mabilis. Kasi hindi siya masyadong exciting kasi history yun eh. Pero at least alam nyo na yung mga natin na paano na gano yung computer natin components, no? Yung layer, no? Kasi yan naman talagang pinag-uusapan dito sa computer architecture. Okay, so nagsimula yan ng tas nag-end tayo sa PCI. Itutuloy pa natin yan sa Lunes, huwag kayong mag-alala. Okay. So, i-check nga natin. So, gising pa? Okay.
Gising pa po.
Gising pa.
Gising
Okay.
pa po.
So, magigising na tayo ngayon kasi nakaharap na tayo sa ating mga devices. Okay. First thing first, mag-i-install tayo. Install natin si NASAM. Okay. Okay. Nandiyan ba yung mga ano nyo? Mga units nyo? Okay. Okay. Kailangan muna nating install. Okay. Si NASAM. Ano nga ba yung ginamit ko dati? Ano? Anong gusto mo? Teka lang. Sandali. Environment setup. Teka. Ano raw ang ating, ayan, installing. Okay. Ayan. Doon tayo sa NASAM. Hanapin ko lang si NASAM. Okay. Nakikita nyo ba yung screen ko? Hindi.
Hindi po.
Hindi po.
Ipo-post ko na lang yung ano ha, dali. Po-post ko sa GC natin yung ano kung saan ida-download. Or kung
Sige po, ma'am.
naka-internet kayo, pwede nyo na rin hanapin. Google. NASAM. Install. Okay. Ayan. Si NASAM. Nasaan si NASAM? Okay. Copy. Lagay ko na po. Ando na po sa ating GC. Okay. Ayan. Paki-download po para ready na tayo. Okay. Okay, NASAM. Mag-install din ako. Mag-install na. Okay, download. Anong sabi? Teka, anong sabi? Ano raw ang i-install? To install, select where is NASAM urbanism already. Okay. So, sabi yung latest daw. So, sige, yung latest ang i-install natin. Hala na! Ano? Masakit. Nag-dive ka kasi. Kulit-kulit mo. Okay. So, yun daw, latest ang ating install. Okay. So, alin ba ang latest dito? Got it. Tinga. So, ang anong latest? Okay. So, ang latest yung nasa ibabaw. Okay. Okay. Ayan. Yun. Sinasam. Yung mga machine natin na nakalagay dyan, kung 64-bit o kung meron pa bang gumagamit sa inyo ng 32-bit? Class? Meron? Wala naman. Ayan. Wala naman. O, ayan. So, syempre, dapat pipiliin nyo kung ano yung naka-assign na hardware sa inyo, ha? O, sige. Kanya-kanya na tayong download, ha? Mag-i-install na ako. Okay. Okay. Papakita ko ba yung aking installation? Sige, pakita ko na rin para masaya. Okay. NASAM extract all. Extract. Okay. Track all. Ay, tumatakbo na ba? Nasaan na? Install. Na-install nyo na? Na-install na po ba? Pwede pong mag-comment. Yes po. Ayan, naka-install na raw po. Yes po. Okay. Ayan. Since naka-install na, pwede na tayong magsimula, no? Ayan. Para masaya, meron tayong papakinggan. Mas maganda yung meron tayong naririnig eh. Kaysa yung ako yung dot-dot ng dot-dot, no? Nagsasawa na kayo sa boses ko. Ito kasi pinakinggan ko na to eh. Pinakinggan ko na si Kuya. Nasa assembly. Buksan ko lang ha. Sandali. Yan. Enter. Okay. Teka. I-share ko lang yung ating tutorial points para meron tayong pinaka main reference. Ayan, copy. Si-send ko po sa ating GC. Ayan po yung ating reference. Si tutorial points. Tapos po, ayan, pwede na tayong makinig. Ayan. Okay. Nasam programming.
16 bits on it, so it's this larger bit, larger section, and then the very basics of assembly, what the
Okay, share ko lang yung video. Ito yung ating introduction na para may idea tayo kay NASAM. Ayan. Okay. So, hindi ko siya lalakihan kasi puputol yung ating recording.
The very basics of assembly, what the operations you can do are, how to do registers, how to interact with the stack, and we will also go over how to write assembly code, essentially structuring it like C and then breaking down the major commands you'd find in C. We'll then do an example or two and answer any questions afterwards. So to start, we'll start with what assembly is. So assembly is the essentially the human readable version of machine code, where machine code is just, ones and zeros in giant files. Assembly is the text version of what those ones and zeros mean, where a byte operation might mean move EAX, EBX. And so this means that assembly is basically the lowest level that you can get to machine code. C is advanced, like, combinations of assembly commands to make larger operations. And you'll see what I mean by that a little bit later. But what this means is that a lot of the things you'll find in C and in higher level programming languages don't exist here. And by the way, you guys are welcome to ask questions anytime throughout this. Just feel free to interrupt me as we go. So what I mean by not having the same structure as C is that everything in assembly is just binary. It's ones and zeros. There's no concept of integers versus characters or other things like that. The only main difference is addresses versus data. And so if you've learned about memory, you know that data is stored in memory at a specific address, and the address is usually represented in some hex value. But to assembly, this is still just a number. It's how we treat the data that we're representing that makes it a character or a string or an array for us. But to the program, to assembly, there's no such thing as data types, so you don't have to worry about conversion errors when you're compiling, stuff like that. On the flip side, you have to keep track of those conversions for the data that you want to present. And for example, ASCII codes, which we'll talk about briefly, have to the computer they're just numbers, but to us we represent character A as some hex number, and you need to keep track of, is this number a character, or am I treating this number as a character, or am I treating it as a number, or as an address, or as anything else. So you need to keep track of your own data types, is the moral of the story there. Alright, let's get into the structure of an assembly file. So you've got three main sections. You've got the section.data, you have a section.bss, and you have a section.text. Now I think you're far enough in the class that you've seen this before, but essentially the section.data represents it represents where you define constant variables, or define variables. We'll start with that. We'll start with define constant variables. What we mean by this are this can be strings, it can be magic numbers. If you remember from 201, magic numbers are any constant number that you use in your code. It can be terminating lines, terminating strings. It can be pretty much anything like that. Anything that you already know the value of will go here. Now the section BSS is the opposite, and these are reserving space and memory for future variables, for future data. So essentially this is the equivalent of making a variable in C, and in C, for the .data section, you might say int a equals 1, and then you don't change the value of 1 throughout the thing. You just have this magic variable 1 in your code. But you might say you're going to read in a string from the user. You would say char array a equals, my C is a little rusty here, but you might do something like that. Char a equals, and then you might have, you just set it all to character zeros, where this is essentially a zeroed out array for a 3-character string that you're going to read in later. You don't know the value now, but what happens is when the computer starts up your program, it's gonna reserve this space in memory for a 3-slot thing. So essentially, you are creating spaces to store future variables, is what the BSS section is for. Then you have the .text section. This is where your actual code is going to be. Your .text section will have a label in it. It'll have multiple labels, but the labels are essentially marked addresses in your code that are stored in a table. And when you jump to labels, you will reference that table and essentially know where to go in your code. The .text section always has one label in, it's either start or main. So it's either one of these two. And it depends on... It depends on what compiler you're using. So there are two steps to compiling assembly because you don't have the niceties of C code. The first one is a linker, or an assembler. In this case, we use the NASM assembler. This will convert your assembly code into essentially the machine version of it. And what this outputs is a .o file. File.o. The next step you have to do is you have to link your code. And linking, one of the big things linking does is it actually combines multiple libraries. So if you, for example, use a C function, it has to be included and thrown into your file. And linking also does a couple other things to clean up your code. Now there are two different ways you can link. The first is using the dynamic linker, LD. And the second is to use GCC. If you use LD, then you need to use the start label. LD looks specifically for the start label as its entry point into your program. GCC is going to look for the main label. So you can use either of these, it just depends on what you want to use for your linking. The linker takes the .o and turns it into an executable file. You have to specify what architecture and the size of your memory space that you're working with when you compile code. And for, I believe, most of your 310 assignments, you're going to be using ELF32. And, yeah, it's wrong. And you will be using 386. And essentially what this means is it specifies the width of your memory spaces. And it allows you to use EAX versus RAX, which we'll talk about the difference in a second. But RAX is a 64-bit register, so you'll need to use the 64 version that we had up earlier. Meanwhile, EAX is a 32-bit register, and you'll use the 32 versions. Now, if you're using 64, you can still use the 32, but it sets a maximum, depending on which one you use. Alright, so let's talk about registers. If there are any questions about this, you can just interrupt me as you please. So registers are hardware variables, are hardware implemented variables. And what this means is there is a set of transistors in the chip that holds data, and it is only 32 or 64 bits wide, but it is a hard-coded variable, and it will always exist. And these are the things that you perform operations on. So when you want to perform operations on data, you have to load them into those hard-coded variable spaces and then perform the operations on them, because the operational logic inside the processor interacts with those transistors that make the register. So that's a slight hardware explanation. What you can think of in terms of code is that these are variables that you need to use to do operations, and we'll see some examples of that later. So the best way for me to show you registers are with a picture. So there's this nice picture from Virginia State in their comp sci program. As you can see here, you've got a bunch of different registers to use, and this is only some of them. But the main general purpose registers are EAX, EBX, ECX, and EDX. These are going to be used for almost all of your operations and pretty much everything else you do. Now, they come in a bunch of different sizes. As we said before, RAX, which isn't shown here, is 64 bits, but they all share the same transistor space, which means that these lower 8 bits AL, this is a register you can access in your assembly code, and it's the lower 8 bits of the entire EAX register. So if you put a variable or data in EAX, and it's 32 bits long, and then you put a variable or data in AL, it's going to change the lower 8 bits of EAX. So you have to keep track when you're writing code. Am I already using EAX? If so, I don't want to write to AL. I don't want to write a different data point to AL because it'll change my value of EAX. So EAX has the lower 8 bits AL, the upper 8 bits AH, and these 16 bits together form AX. And then EAX is an additional 16 bits on it, so it's this larger bit, larger section. And then RAX is actually double this size. They add another whole 32 bits. But you can't access these upper portions of it. You can only access these lower portions by accessing the lower sized registers. Each of these has a general purpose use. The ECX is generally called the counter register because we use it for incrementing and loop iterator variables. And there are actually hardware implementations of operands that allow us to do increments slightly faster or with a little more efficiency if we use this register specifically. Then you have EAX, which is I think called the accumulator register. This is used as the result for most of your arithmetic operations. They are stored in EAX, but we'll see that a little later. Another thing worth pointing out are ESI and EDI. These are primarily used for copying large pieces of data. So ESI is the source index and EDI would be the destination index. And we'll see that in use in a string operator a little later. These are also general purpose, so you don't have to use any of these for a specific thing, but this is like the general idea for how they came up with these registers. And then, if you've heard of the stack, you have 2 pointers to the stack, one at the bottom and one at the top. The top one will be moved every time you add or remove the data from the stack. That's the ESP, the stack pointer. And then EBP, the base pointer, points to the bottom of the stack so that you have a reference of how large your stack is and when your stack is empty, because it'll be empty when these two point to the same address. Alright, so let's get into some code. And I'm just going to hit enter a couple times. So we need to build some, we need to introduce some operands that we can use for our normal day-to-day coding and assembly. The first and probably most heavily used is going to be the move operand. This is essentially, or I guess they're called instructions. The move instruction is going to copy data from one location to another. So it's going to copy data from a destination address to a source address. And these can be registers, these can be variables declared in .data or .bss. And you'll see plenty of examples as you work on this. You'll become very familiar with move. There are a couple other versions of move, and these have to do with the size of the data you're moving in. The first is move ZX, and this is used to zero out the rest of the register that's unused. So for example, if I say move ZX EAX3, this is going to put the binary version of 3, which is 1, 1, into a 32-bit register. So we're only using 2 of those bits. It's going to zero out the rest of them. Now it'll probably already do that, but when you're doing something like pulling from memory or telling it to, for example, move ZX EAX byte pointer EBX. What this line means is that we are grabbing 1 byte from the address stored in EBX. And for example, EBX could be an array, such as this A thing we saw here. We only want to grab 1 byte. But EAX is 4 bytes in size, 32 bits. So we're going to zero out the other unused bytes in EAX. The brackets are used for dereferencing. If you've heard of that in C, essentially this is an address, you want the data stored at the address, so you use the brackets. These are going to be used for both data and BSS variables. And if you're ever working with code and and you try to grab data and it comes out as an address, just know that you probably need to switch the brackets because you might be using them in the wrong situation, or you might not be using them when you need them. There's another one, move SX. And what this one does is the exact same thing as zero extent, except it's sign extent. So if you put in a negative number that's only 1 byte in size, but you have a 4 byte register, it's going to sign extend up to the end of that register. Alright, so that's move. You have bitwise operations such as AND. You also have OR, XOR, and test. So all of these are bitwise operations, which means they don't go byte by byte. They actually look at the individual bits in the two datas you give it. And AND is going to AND thing A, thing B, and store it in A. OR will do the same thing. XOR will do the same thing. Test, on the other hand, won't change the destination register. Test is going to check whether or not they're the same thing. And so what we can do is say test EAX, EAX. And test is going to, this line will check whether EAX equals 0. And it won't change the value of EAX either. It only updates the flags register. We'll talk about the flags in a second. You also have the, I'm going to hit enter a bunch of times so I can type in the center of the screen. You also have your arithmetic operations. So you have add EAX EBX, which is just EAX equals EAX plus EBX. You have subtract EAX, and you can use, this is just an example, you can use constants or you can use variables, doesn't make a difference. By the way, the semicolon is a comment, it's not the end of a line like in C. So you have subtract EAX, which says EAX equals EAX minus 15. You have multiply, and multiply and divide are a little different. You would move AX 15, and then you would multiply BX. And what this is saying is DX colon AX equals AX times BX. So the reason we have, and this is why it's called the accumulator registers, because it's the set destination. You can't tell it to store it somewhere else. It always stores it in the A register. Now what we have here is this DX colon AX. This is because multiplying two 16-bit registers together might give you an answer that's more than 16 bits in size. And so anything greater, the lower 16 bits of that result would be stored in AX, and the upper 16 bits would be stored in DX. This is important if you're multiplying two big numbers together, because you always need to take into account the DX. In a similar situation, divide is going to say AX remainder DX equals DX AX over BX. So this is saying I might have a 32-bit value that I want to divide by 16 bits, and the result is going to be stored in AX with the remainder stored in DX. So again, this is so that we can do larger sizes of variables in these operations. And this...
Okay, class. Napansin nyo yung addressing nila, diba? Kung nakikita nyo yung addressing nila, so tandaan nyo yung kung ano yung gamit nyo na hardware, no? Yung lagi sinasabi yung EAX. Okay. So, ina-address niya yung space na iaalat mo doon sa iyong screen, no? Yan. Nakita nyo medyo tedious yung coding natin kasi nga assembly to, no? That's exactly how is it going to be called, no? Anyway, so ayan, 3:30 na tayo. Ang importante na install nyo na yung ating NASAM. Okay? Here is what you can do para maging ready tayo next meeting. Ayan, na-install nila. Tama, ayun, si Juan Paulo. Yun nga yung iniisip ko kanina pa. Hindi ko matandaan yung pangalan. OSI, halamat. Yung ko lang nakita yung comment. Ayan. Yun na yung latest, no? Yung presentation layer. Ay, yung OSI model. Anong ibig sabihin ng OSI? Anong ibig sabihin ng OSI? Yun yung kanina ko pang iniisip nung pangalan nun pero pinakita ko may presentation layer, transport layer, yan. Ano yung sabihin ng OSI? Yung mga network guys dyan. Hindi. Teka ha. Alam ko yung laman ng OSI, pero hindi ko matandaan kung ano ibig sabihin ng OSI. OSI. Model. Oo nga, no? Open system. Open system interconnection. Ayun. Yun daw. Open system interconnection. Tama pala si Nasasa na yun. Nasa yung ating Open system interconnection. Tama si Juan Paulo. Alam ko mali. Ayan. Okay. So, para maging ready tayo sa next natin, sa next Friday. Friday lang yung schedule natin ng NASAM, no? So, sinend ko na yung ating i-ano ko yung link, i-share ko yung link, yung mga gustong mag-ahead. Ayan. Tapos, nag-send na rin ako sa GC yung tutorial points para may idea kayo. Sinend ko na yung crash course. So, ang importante, nakapag-install na kayo ng NASAM. Sa NASAM, iba yung saan ka magko-code. Tapos, pag kinompile mo siya, kailangan mo pa rin ng gagamit tayo ng kung ano yung i-ano mo, kung GCC, yan. Mag-i-install ka pa rin nun. Tapos, yung linker na tinatawag. So, meron pa tayong i-install na either, depende kung anong gagamitin natin, kung GCC or Ayan. Tapos, meron pang isa yung linker para makita natin ang buo yung ating gagawin. Ayan. So, pero itutuloy na lang natin yan next meeting kasi 3:30 na. Baka may klase pa kayo sa ibang ibang subject. Pero, ayan. Sinend ko na sa GC yung ating kung gusto nyong mag-ahead, pwede nyo nang i-browse. Ayan. Or gusto nyo ituloy nyo yung pakinggan yung ating tutorial. What I will do is, as we go along, i-explain ko yung ginagawa natin, no? Ginagawa nung tinuturo ni Kuya. Okay. So, yun lang po. At oras na yung ating ubos na yung ating oras. Okay. Yan ha. Yan ang ating gagawin. So, yun muna. Doon muna tayo mag-ending. So, sa next meeting ay diretso natin yung ating historical background ng ating computer architecture. Ayan. Yun lang po. Nagbigay na ako ng instruction para maging ready kayo. Pwede nyo i-access na lang doon sa sa GC natin. At itong ating recording ay ko na rin. Ipopost ko doon. Ayan. Buti hindi tayo naputol. Dire-diretso yung ating Okay. So, yun lang po. Unless meron po tayong gustong idagdag, meron po ba kayong comment or gustong sabihin bago tayo maghiwa-hiwalay? Class, are you still there? Tinulugan nyo na ako.
Nan na po sa akin, ma'am.
Yung ating discussion kanina, kaya pinahapyawan ko lang yun kasi historical background lang naman yun. Hindi ako masyado nagko-concentrate doon. Importante lang, alam niyo yung paano nabuo yung components ng computer hanggang sa maging OSI na siya. Ayun. So, ayan, naging layer, tapos naging PCI. Ayun, yun. Kaya medyo naboboryong na kayo eh. Ngayon ginawa ko, dinire-diretso ko na lang. para dito na tayo sa exciting. Ito yung makukulta yung utak natin, no? Sa NASAM. Ito na yung mas nakakakulta. Ayan. So, pag-isipan nyo na, ayan, ahead na kayo para pag nagsimula tayo ng coding, may idea na kayo kung anong gagawin natin. Okay? So, yun lang po. Pwede po bang, kukunan ko lang ng, print screen para sa attendance. Ayan, may instruction kasi sa school. Ilabas lang po natin yung ating mga gwapo at magagandang mga mukha. Ayan. Para makuhanan po natin ng print screen. Ayan. O, huwag nating lagyan ng Kung gusto nyo maglagay ng gano'n yung mas maliit. Ano nga tawag dito? Ayan. Mas maliit. Ang laki kasi cover na agad. Ayan. Hello, sino po yung Okay. O, Mikaela, may video ka ba? Ay, may yung mukha mo para makuha na natin ng G, Bacaro, Francis, Cherian, Kian, Lance, Charmaine, Kenneth, Rogelio, Melrose, Ron, Josiah, Sophia, Eman, Corby, ayan, Eman, Josiah, Kenneth, na, okay, kukunan ko na, dali, bilis na, buksan nyo na yung mga video nyo, Kian, Charmaine, Lance, si G Bacaro, tulog ka na ata, G, Melrose, tulog na ba si G? Okay, kukuha na ako ha. At least may mga picture yung iba. Itong si G, hindi nakapicture eh. Lance, hindi ka nakapicture. Naka-icon ka ng ano ba yan? Okay. Sandali, ilipat ko lang yung names. Para yung names nyo ang nasa Ayan. Okay, smile naman dyan. Okay. Create screen. Ayan. Okay, salamat. Yan lang po. So, wala na po tayong So, para ma-appreciate natin yung ating COA, ayan, mag-a-assembly na tayo. Okay, so wala na po ba kayong gustong sabihin bago tayo maghiwa-hiwalay? Ayan. Yun lang po. Okay na po. Wala na po. O siya. Bye-bye na po.
Thank you po, ma'am.
Salamat.
Thank you.
Thank you po, ma'am.
Ingat tayo. Ingat tayo. At weekend na. Okay? Hindi na tayo naka-face mask, ha? Mag-ingat. Sige. Bye-bye. Ayan. Yan pa yung iba. Ayan. Right. Salamat. Okay, bye-bye. Si Rogelio. At saka si Ron. End ko na, ha? End na. End. Okay.